Okay, so I think looks like everybody's made their way back in the room, so if you could try to get settled as quickly as possible. So as I mentioned, the plan for the next 30 minutes or so is to have a open discussion where the experts here, assembled here, have a chance to share their perspectives on some general issues of importance, but then also that will allow questions from the audience of any of the speakers or to the panel at large. And so this panel now will include the people that you've already heard from, but also two special guests, as I mentioned. We're joined by Dick Norris, who's my colleague here, professor at Scripps, and then Rick Murray, who was Margaret's, was he your first suit? Postdoc, okay. But instead of having me ramble on, I will let them self-introduce. And so Dick, you're up first because you actually have visuals.
I have slides, yeah, that's right. Yeah, so I'm Dick Norris. I'm, as Chris said, a paleoceanographer, and so I share that kind of historical background with Margaret. And then I'm also a paleontologist, and I'll squeak some paleontology into this little presentation in just a moment. But I wanted to start off with scientific ocean drilling, which has been going on for a long time. It was founded here at SIO back in the 60s. And our connection to this symposium is that Margaret was one of the co-chiefs on leg 92 on the Glomar Challenger over there back in 1983. And here she is with Dave Ray as both the real chief scientists in this case. And I don't know if you were one of the first women, certainly, to be a chief scientist. I don't know who might have predated you, but anyway, quite the inspiration, okay, for those who came afterwards about trying to have a more diverse group of people in the science parties. And then another leg that Margaret was part of, she was a sedimentologist on leg 138, which sailed on the Joides Resolution over here and ended in San Diego, hearkening into her becoming the director here. But leg 138 is really, to me, it was a watershed time because it introduced this paper here that Margaret's part of called color reflectance spectroscopy. And this was the idea of using the sediment color to tell you something about geologic history and the environments in which sediments were deposited. And so we start off here with a core, which has light and dark colored banding through it that turns out to be climatologically driven. And we can take cores like that, and I've sailed on a cruise with Chris, actually, where he was the stratigraphic correlator, where you take a series of different cores that have been drilled repeatedly through the same stratigraphic interval, and those are the red, blue, and green records over there against depth. And then you can stack them together, okay, to make a continuous composite record that shows you the entire history. Because the problem is that an individual core will have gaps in it, and so you want to get rid of those gaps in order to get a continuous record. And I say that this is the start of a revolution because it really gave us deep insight into geologic history. And so right now we can do this kind of thing. This is much more recent, you know, here's 65 million years ago to 25 million years ago, and then the other diagram 20 million years ago to the present. And you see these core photographs down below where we've done the same kind of compositing to stack up an overall really detailed record of Earth history as seen from the oceans. And right now that's at sort of roughly century to millennial type timescales where we have this 65 million year long record. Now the key point about that is it gives us two key pieces of information. You know, one is it answers when did various events happen in Earth history? And then very critically for the stuff that Rick will probably talk about, you know, is how rapidly have things happened. As a geochemist, you're interested in the rates at which events have taken place because rate gives you some idea of the underlying dynamical cause. And so Margaret was there at the beginning of all that. So then I'm a paleontologist, so I've got to squeak in some paleo. Okay, here we have 115 million years long record that comes out of doing all that kind of compositing and figuring out the timing of events. And I just put a variety of things up there. So we start off with the greenhouse world up there in green that transitions into the modern icehouse time when things become glaciated at high latitudes. And that accompanies down at the bottom the existence of forests on most of the continents that transition in mid-latitudes into grasslands. And just one other thing to point out is the big baleen whales there. They're a young feature, okay? That's just the last couple million years of Earth history that we've actually had giant whales. And the whole point is that we can now stack together this beautiful record that comes from scientific ocean drilling fundamentally to put all of these different events into this broader context of Earth history. Okay, my last little squeak as a paleontologist is to show you some of my latest data. And so this is the record of the mass accumulation rates, or MAR, of two different species of foraminifera, which I happen to work on. And so the red one there with the red diagram is a species that likes the Indo-Pacific Ocean, and the blue one is a species that evolves within the Caribbean and in the Atlantic, but is not found elsewhere in the world. And you see this remarkable pattern that comes about by counting these things, just the stupid thing of just going out there with a microscope and counting the abundances of different fossils through time. And we see the fluctuating occurrence of the Indo-Pacific thing that goes in and out, in and out. It kind of flickers like the light switch flipping on and off, leading up to the emergence, in this case, of Panama as a complete barrier between the Pacific and the Atlantic. And at that point, our Atlantic endemic turns up, okay, the blue record. And then something else happens. We start getting into an Atlantic Ocean that is much more Pacific-like, and sure enough, our Pacific endemics turn up once again. So my basic message from all that is that by looking in detail, we've done a lot of this kind of detailed work with geochemistry to try to put together an Earth history and climatological history, and we can do the same thing with the microfossil record. So with that, I will turn it over to Rick. And I don't know, can we make this go away? Or is that?
Oh, it's beautiful.
I don't want it to go away, actually. I should.
Oh, it went away. Okay. Thanks. Oh, I get to still see it on the computer, though, so I'm good. Hi, everybody. So I started scientifically working with Margaret as her postdoc, as Dick said, or Chris said. I was actually her only postdoc, and so I guess if these comments, don't resonate so well, you can say, you see, that's why I never had another one. So then subsequently worked together on science, certainly through the 90s and the 2000s, and then also eventually when I moved to NSF as Division Director for Ocean Sciences, then when I was in leadership at Woods Hole. I'm currently a Senior Scientist Emeritus at Woods Hole. And then also at the AGU and several other places. And it's really terrific to see NSFers here, AGUers here, where's Janice, as well as Chris, and everybody else from, through these, overlapping times and careers. Having said all that, I honestly almost can't remember not knowing Margaret throughout as a professional. I mean, I remember reading papers of yours when I was in college, and which is why part of the reason I ended up choosing what I did for grad school, and then obviously for postdoc and so on. So it's a little weird, honestly, speaking about someone you've known for so long in many different ways, certainly dominantly professionally, but also certainly personally as well. So my colleagues have spoken a lot about paleoceanography and so on and so forth, and a lot of the work that they've done and that simulated by Margaret. And I'm not going to take that approach. I don't have any slides. And I'm about a third of the way through, already. So you're that much closer to the panel conversation and then, of course, all-important lunch. But I want to speak about a different aspect and more about how Margaret, at least for me and many, many others, really stimulated people to look at the fundamental composition of the sediment itself. And we heard about that with dust, and we heard about that with everything else. But it's really fundamentally based on what is that mud made out of? What is it? What are those signals? What is the record telling us? And that was part of what I found so stimulating working with Margaret, and where I think if we look at this symposium also as talking about future of oceanography, future of sediment in particular for this section, I want to, talk about, a new growing field. I do have one anecdote from Jay Goff's days. Gisela, you put a map up from that time period. So when I was a postdoc, and we had written a proposal to the wonderful, wonderful people at NSF, who in their infinite wisdom rejected it quite soundly and effectively. It's all about efficiency. And it didn't go over that well. And I don't know if you actually remember this, Margaret, but we were walking from your office, my office, to your office down in Fish, and a building at GSO. And you said, when you get reviews like that, it makes you wonder why you're even doing this at all. And that was really impressionable to me, because I was a young pup just starting out as a postdoc, working with this amazing scientist who is clearly, killing it. And, I'd chosen to go there, and by the grace of, whatever you're into, she chose me, and it worked out. But that an esteemed, successful, accomplished person like that could demonstrate that personal vulnerability and professional vulnerability made a huge impact on me as a person, because we all have ups and downs through our career. And that she showed that to me, that it's okay to be like that, to take that risk, was incredibly rewarding at the time, as well as an unfortunate lot of many other times where we all face rejections from NSF or anything else through the years. So anyways, to get to my point about where I see future opportunities in oceanography or subsea floor oceanographies, I want to turn to microbiology and the biological role of what's going on the seafloor and in the seafloor. I've been peripherally involved in it myself through the good graces and good colleagues I have, many of them at University of Rhode Island and elsewhere, but I don't do it myself, so I kind of know enough to be dangerous. But following your lead, Margaret, of sort of fearlessness and jumping into something new, jumping into something that's really challenging, and following the fact that I don't know if many people are aware of this, but Margaret, through her work with UN, is heavily involved with OBON, which is the Ocean Biomolecular Observing Network, which is essentially a water column focused, I believe, effort. I'd like to see, and I think there is a huge opportunity for an OBON type, or maybe a census of marine life meets OBON for the seafloor and below the seafloor, on a global basis, to actually see what the biological processes are that are going on, that are controlling the composition of the sediment, that's regulating a lot of the chemical reactions that Evan spoke on, and that is controlling so much of what we see in the seafloor. And I truly do mean, if we're going to understand this ocean and the climate system, we have to take a global look. There's been a lot of good work in this environment, a lot of good work in that environment, but we need to get very systemic about it. Focusing on, mid-ocean ridges to the estuaries, sedimentary processes, the energy sources and sinks, codependencies with the mineralogical variability, the role in weathering, what are the microbes doing in these different areas, I think is a real gap that there's a huge opportunity that we can do, even in the absence, hopefully temporary, of ocean drilling, but the upper 20 meters and getting down to those depths on a global basis, I find really, really exciting. And if I was a cat with 9 professional lives, it would certainly be something that I would definitely be going into. Given all the environmental forcings that are controlling the microbial activity on the seafloor, what's the diversity? How does that diversity compare to overlying water column diversity? Is there a condensing? Is there as things are decaying, are they converging down into a more common consortia? Or any of those questions, we just don't know the answers to. And I think that really will control a lot of what we're seeing in the sediment. So I think just as we've learned so much from the water column and the interrelationships between physics, chemistry, and biology in understanding the behavior of carbon in the ocean interior or what have you, we need to bring much more biology, and therefore microbiology by definition almost, into the seafloor environment to understand Earth and climate history. So back to those reviews from Jay Goff's a long time ago. Pursuing the future is going to have its ups and downs, and this is definitely true in this current climate. But if we can inspire the next generation or mid-generation people who are interested in trying something different, they might be comfortable with where they are, but they want to maybe shift. That's where I would go. I would go into that microbiological world below the seafloor. I would not be dissuaded by either the scientific, the political, or the financial limitations. As Margaret herself has taught us all so well, things are likely going to turn out all right. Thank you.
Okay, so thanks, Rick. We're going to open it up to a more, I hope, expansive panel discussion. And so that will include questions that you may all have for any of the panelists. But before turning it open to the all of you random participants, I thought maybe we could just have a sort of discussion of sort of priorities and challenges and opportunities that would, in terms of this discipline and pursuit of sampling the seafloor for its record of ocean history and chemistry. With that, I thought I would pose maybe a couple of general questions. I mean, we've heard reference to the decadal surveys of sort of identifying the kind of state of knowledge of a field or the discipline of oceanography in general, which Margaret was a big part of initiating. And that identifying priorities for the future. So I just wanted to ask the panel members, and maybe we won't start with Dick and Rick because they sort of touched on this in their self-introduction, but for the speakers, what would you say would be, and this is irrespective of the resources that are available now or the technological capabilities that exist now, but what would you say would be the top priorities for what you'd like to see coming out of your work or just related work in the next 10 years? Yeah, Tim?
So I wanted to pick up on something that Rick Spinrad said in his excellent talk, and I was also just talking with Paula Bontempi, and that's impact. And I think we really need to be focused. It has many meanings, but I think we really need to think about impact, and maybe particularly in these days, direct impact on humans. And Rick's comment in general, but particularly the idea that the world relies on the majority of its protein from the sea. So one thing I think we have underutilized in the Earth's past is a deeper understanding of ocean ecology and ecosystems. You know, the role of those tiny organisms floating passively in the surface water that are, determined by the wind mixing and the density and the sunlight, and how they respond on decadal and longer timescales, the timescales that we haven't really observed well. And the problem is biology is much more complicated than physics and geochemistry. I say that as a non-biologist. So the rules of the game are harder to understand, but I think it's only by looking at sort of more time average responses that filter out some of the randomness and the short variability that we can kind of get deeper lessons. But those lessons apply to the base of the food chain. And it's not, and in complex ways, it's not only how many there are, but who's there that is going to determine food webs. And I think this is still a very much underexploited aspect of the Earth's past. It's not that nobody has talked about it, but the physical aspects, the geochemical aspects are quite a bit easier. And frankly, the field is dominated by those of us like that. And so I think we need to turn more toward the intersection of those physical chemical processes with ecosystem structuring and the rules of the game.
Yeah, thanks, Tim. I think Dick might agree with you there.
I'd actually tried to make that point probably badly. With my last slide, there's a reason why there's all those fluctuations in the abundance of microfossils, and they're almost certainly reflecting, the surface water oceanography. And many of our geochemical proxies, you think about oxygen isotopes, for example, largely reflects high latitude processes that are affecting the nature of the deep ocean. And so trying to understand the surface ocean environment, I think, in various ways, geochemically and also paleontologically, is very worthwhile.
I guess I want to echo what Rick said about distribution and metabolic pathways in the subsea-floor biosphere. Is also something that I think is also really critical, as Rick had mentioned. A lot of the work I do is geophysical in nature, and so actually making observations in dynamic environments, in situ observations in 4D is critical. A lot of work I do is in subduction zone systems, and so being able to do offshore geodesy and hopefully get that in real time, but techniques for making measurements of position, pore pressure, strain in certain tectonic environments is moving forward, and I think there's a lot of room to grow. Subsea floor observations and perturbation experiments, where we use deep borehole observatories, for instance, is something that has started and certainly can be expanded to better understand dynamic processes on Earth and how they affect society, particularly in subduction zones. That's all I got.
I'll just, add, echoing sort of what the others have already mentioned, that, I think it's not just, not merely impact, it's also that we actually need to think differently about what we research and make it more driven by the questions that are important. And, to me, this is mostly the climate crisis, and so it's mostly about the carbon cycle. And the recognition that, similar to what Tim said, I completely agree with this. We haven't done a terribly good job. I know it's sort of cliche to say we need to all work together and bring the chemistry and the physics and the biology together. And we always do say that, but none of us does it truly. And so I think that's sort of the challenge for the future. And then work on these key questions that are truly important. To me, that's the carbon cycle.
I'll just chime in. Is on? Yep. I'll just chime in briefly a little bit. Lahini and I had the privilege of being on the most recent National Academy of Sciences decadal survey, and it was just released 2 or 3 months ago. I do urge everybody to read it. It's a very, I think, compelling report. The subtitle of it, or maybe the main title of it, is about forecasting. And it's not forecasting in the operational sense of exactly what's going on at such and such latitude, longitude at such and such a time, but it's really trying to develop a better understanding of all the processes going on in the ocean so we can see what is the ocean going to be like in 8 to 10, 12 years from now. And it's oriented specifically around some of these points you folks are bringing up in the sense of the interrelationships of all the different processes, as well as going about science in a different way in terms of who we involve, how we involve those people, and what questions we allow ourselves to ask. So it speaks to some of these points as well.
Okay, great. Thanks. So I think in the interest of time, why don't we move on to, I posed my first question for the panel as being irrespective of resources available. So now I want to actually get your take on the importance of having a sustained observing system of the marine sediments. And in particular, we're all connected up here on the stage by virtue of our involvement with the IODP program and connected with Margaret in that way. And so 6 degrees of Margaret. But so the question is, what do you see as the primary value of keeping that type of observing system going and sustained into the future? What are the primary benefits, and how would you argue with someone who might say, well, look at the map of seafloor sediments, we have tons of sediment cores, we don't need any more. Why go out and new expeditions and make new observations of sediments? So I'll open that up to anybody here on the panel.
So if you look at the map, in fact, there are a lot of dots in the world, but about a quarter of those were drilled with rotary coring, which completely chews through soft sediment, which happens to be the most recent few million years of Earth history, in a way that makes it very hard to accurately reconstruct. And it's important to note the program's had a lot of technological development. Those beautiful cores I showed, those were the first time a new technology was deployed 2.5 years ago. I was out at sea, that radically changed the quality of what we get, stop mixing and preserve fidelity. So the technology is not, in fact, completely mature to get the best records and drill in the most difficult locations at all. That's important to note, that it's not only a ship, but the technical capabilities and improvements that we can hope to project into the future. One more thing is that each leg that goes out, or expedition, has a certain mission. And many of those missions, they were well-founded, but they don't capture the science we might want to do today. So we look at where we are in 2025, we would go and do things quite differently for good reason, building on what we've done. But we don't know a tenth of what we need to know as far as understanding Earth's past climate.
I'll say two things that are kind of more, I guess, fundamental, is that, not having the ocean drilling program to a marine geologist is like if you're doing oceanography without a CTD caster or rosette, right? You can just image the subsea floor, but you can never sample it if you don't have the tools to do so. And so I've had a couple examples on lakes that I've been involved in where we had a prediction of what we might core based on seismic reflection data, and then we core, and it's completely different, and changed the entire hypothesis and field just by collecting a physical sample. So I find it very critical. The other thing, and this also is related to what Rick was saying earlier, is for someone like me who looks at pore water and microbiological processes and things like that, our samples have a shelf life. And so we don't have core records like the sedimentologists do. The records have finite, and so we don't have legacy material from which we can do measurements on. So having the capability to collect those samples allows us to progress in the science.
I would say that, if you think about the CO2 record, we had just a couple of years of that, we would understand something about the dynamical system, I think. But we wouldn't have any appreciation for where we had come from in terms of CO2 in the atmosphere. And so long time series, get you at a different set of dynamics than short time series do. And so seafloor observatories, for example, are critical if you're going to, for example, predict major earthquakes in the Japan Trench. And there it's probably very important to have a long time series where you can observe for considerable periods of time to understand the short and the long sort of dynamical parts of the system. And so I think this comes back to things that Rick mentioned, and also that Margaret, of course, has been a long champion for, which is the idea of major observing systems that continually observe over a long period of time.
Gisela, do you want to?
I'll just say, I agree, right? A lot of the work that we do with this beautiful archive of sediments, yes, we do have that, but is ad hoc and sort of opportunistic. It's not where we really wanted to do it. And I think by rethinking the way we do science, we need dedicated expeditions to actually go out to answer these key questions. So I don't think we need a whole lot, honestly, personally, I think that. But we need the ability to do these dedicated questions that answer these humanity-driven questions. One thing that I find a complete embarrassment for our entire community is that we still don't know what happened to the West Antarctic ice sheet in the last time it was warm. That's an embarrassment. It's really freaky that we don't know this. And so this is the way we should do science, and answer these questions that are really relevant to everyone.
Okay, I think So I will just add one additional thing, and at the risk of going a little bit too woke. So Gisela made reference to her time on the IODP cruise with Christina Ravello, but it is the case that these long coring cruises or long cruises are the sort of place where mentorship happens and the transfer of information from one generation to the next occurs, really. I mean, these intent that they're essentially floating prisons for 2 months. So in that kind of intense social environment, it's just the case that much of the knowledge is passed from our seniors to junior generations, and we are in fact losing that corporate knowledge of how best to go acquire material and how best to observe the sediment. So I think that's a very important kind of tangential benefit. Okay, so Kayla is saying we have just a couple of minutes for questions from the audience for any of the speakers or any of us. So if you have those questions, so let's see. Charlie. Charlie, there's a mic. Come.
I have a cosmology colleague who believes that the possibility of life is built into the chemical table of elements. And so one can expect to find it throughout elsewhere. And we're entering a period in which small planets will soon be discovered or are being discovered, and some of them will be water-bearing planets. To what extent is the oceanography community ready to participate in that debate about the existence of life and water-bearing planets elsewhere?
So far, I think oceanography has very much welcomed it. In fact, a lot of good oceanographic work has been funded by NASA, the division of NASA dealing with extraterrestrial life, and also helping fund development of instrumentation because and remote working, because, okay, it's one thing to do a remote vehicle on the bottom of the seafloor, it's another to a remote vehicle out on Enceladus or wherever you want to look at it. I think there's a lot more opportunity that we can do, but I think the oceanographic community is very welcoming of it because it's somewhat unified by the tie of time. The geological history of the Earth is billions of years, and distances are billions, and planetary ages are also billions. And so it is kind of a unifying way of looking at things together. It's also unfortunately expensive, and it also, however, requires a real commitment for stable, durable funding into the future. Because you don't just do these on a lark and get them done in a 3-year cycle.
Yeah, Jess.
I don't know if it's being recorded. I tend to have a loud voice, but I kind of want to riff actually off of what Charlie just brought up. Thanks. This is Jess Atkins. You'll hear too much from me later today. I think that there are two big themes that have been brought up here about what roles that oceanography could play in either climate or now astrobiology just came up. And the astrobiology, I think it's actually quite different approaches you would take on the two of them, actually. I think you'll hear this from me later. The climate problem has become largely an engineering one. The astrobiology one, though, really puts our feet to the fire in oceanography because we do so much by correlation rather than causation. And we cannot extrapolate the Martin curve, right, of respiration from the Earth to some other protoplanet where we think life might be going on. But if we understood the origins, the mechanistic origins of that respiration, that would work. I'd say the physical oceanographers, I know the theme was supposed to be biology, I'm sorry to come back to physics, but the equation of state of seawater, right? We saw the MATLAB scripts coming up, Tim, on your computer, right? When you used to call those up, they were, 10 years ago, they were entirely empirical, right? Literally, what was the freezing points dependent on salinity in seawater did not have like a basis in delta G, like didn't have a basis in free energy. It does now. A really important group got together and said, this is crazy that we can't take the fundamental constants, and now you could work on a proto-ocean on Mars and think about what the structure of that ocean would look like using modern observations. I think if we were to keep this to the biology, that's where we have to head. Like, we have to go after mechanism, and that's the argument for the basic science, and that's the argument for the continued long-term funding, is that a lot of what we learned in our classes in oceanography is about correlation between things, and we have to understand that causation, that why behind them, if we're gonna go find. I think it's a fantastic question. I think it's so cool, the discovery of the extrasolar planets. I'm a fan of Star Trek, and you know, it was crazy, right, when I was a kid to think that Star Trek was really gonna be true, that there was other life out there. Now it's just likely. And we really have to get ready for being asked this question. I'll shut up.
I'd say in response, partly, you know, that I think that I completely agree, of course, you know, that we need to understand dynamical systems. But I think also that, you know, what we've done in ocean drilling has expanded our minds of what is possible. You know, particularly the whole idea that there are organisms, and in fact, an entire community living in volcanic glass. Like, I find that incredible. It is just that, and that is a discovery that is fairly young on the whole, and it gives you a sense of like what, you know, if you go to other planets, you know, what is the kinds of habitats that I'm also a Star Trek fan, you know, it's not the gorgeous people, you know, of some other planet, you know, that you're going to meet. It's going to be those organisms living in volcanic glass.
They're gorgeous.
Yeah, they are. Touche.
Okay, so I think, oh, wait a second. So there's one.
To add one dimension to the science piece that in Margaret's honor and in this room that we facilitated, and that's, you don't have to sell me, someone like me, 18 years at NASA on exoplanets and what they promise, but I will say the technology and the investment that what we've done as a community in which we've invested as a federal government is utterly instrumental to so much as leaving this planet, let alone exploring other bodies. And the promise of everything from life, which I agree, it's not a matter of if, it's a matter of when, and the discoveries to be made. And I think if the US doesn't continue to invest in that type of infrastructure, that type of partnership, and that kind of technology collaboration, we'll be in trouble.
No. Sorry. Speaking of mashups.
Of course, there are many including
Okay.
That tells you.
Yeah.
It was just about the tech development, the technology development that we have invested in, as an ocean community and as a federal government, and what that means for exploring in general, right?
Okay, yes, and before we cue up the video that was prematurely started, sorry, that was my, I'd like to thank the speakers for their insights today and for joining and their participation, as well as the special guests on the panel, Rick and Dick. So thanks very much for your
As you might imagine, there are many people who wanted to be here and couldn't. And as a result, Kayla has curated a collection of video clips that we are going to view before lunch. And then during lunch, there will also be an opportunity for people to speak to the open mic. So, take it away.
Hello, Margaret. I am so sorry I can't be with you to help celebrate your amazing career at this special event in your honor. You've been an amazing leader in ocean sciences for the many decades that I've known you. We first met when you were a researcher at URI, and I was on the faculty at MIT. Already, you were very well known for your work quantifying the marine carbon cycle. You rose to the position of Vice Provost for Marine and Environmental Programs and Dean of the Graduate School of Oceanography. I also fondly recall your many years as AD for Geosciences at NSF while I was director of MBARI. I didn't realize at the time how important it was to have a world-class researcher and friend at NSF. With all of the shakeups at the federal science agencies these days, it's becoming very hard to find friends in high places. But of course, of your many leadership positions, including Harbor Branch, the most impressive has been your stewardship of Scripps for these past 12 years. You have managed to expand the academic program, double research and philanthropic support, and raise the SIO profile in both climate science and marine policy. I'll do my best to cheer on your successor, but believe me, you are a hard act to follow. As ocean sciences, and particularly climate sciences, face an uncertain future, your timing to retire, as everything else you have chosen to do, is impeccable. I wish you much joy and fulfillment in retirement. Have a well-deserved rest, Margaret, and please say a prayer for those of us still left behind in the trenches.
Hello, Margaret. Congratulations on your retirement. Sorry I can't be with you to celebrate this wonderful occasion, but I just wanted to thank you for all that you have done for the community. You know, I think we met when you were assistant director of NSF for Geosciences many years ago, and I was on the science board, and I really enjoyed working with you. You had already accomplished so much as a scientist in your career then, but the thing I know most about you, Margaret, is your servant heart. You know, serving as AGU president and then being president of Scripps, head of Scripps. You started a nonprofit organization. I mean, you've contributed in so many ways to the community, to our science, and to the betterment of humanity, frankly, through your work with climate and ocean research. We got to serve together on the Waterman Award Committee, where you headed up, I think, the geosciences part of that. And we had some great fun there selecting outstanding young researchers to get that award. It was really a great time. And certainly when I was at OSTP, Margaret, you provided tremendous support. I remember us attending meetings and some banquets together. And it was just really fantastic, the support you provided. Those were interesting times. And I think we did make a lot of progress, but it was only due to the support of folks like you that allowed that to happen and made that happen. So I'm so grateful for all that you have provided to me personally. You've been a great mentor and a tremendous role model for so many people across many, many disciplines. So I just wanted to thank you and wish you the very best. We didn't get a chance to connect when you were on campus here just a few days ago, but I know you're going to enjoy this next chapter of your life and your career, and I wish you the very best. Take care now.
Hello, Margaret, and those present at this auspicious celebration. I regret I could not attend in person. Margaret, I had the pleasure of meeting you during the mid-1970s when you were a graduate student at our PhD alma mater, GSO URI. Since that time, our paths have crossed and blended many times for various activities. Your accomplishments have exemplified excellence in research, education, leadership, and activities at the science policy interface in the local, national, and international arenas. Not all your contributions and accomplishments have received the recognition they deserve. This is the result of those activities exemplifying the adage, there's no end to what you can accomplish if you're not trying to get credit for it. Best wishes as you transition to the next phase of your life. Your colleague and friend, John.